Hey there, future forensic pros. Welcome to the channel that transforms textbooks into tangible tech skills. This is your digital forensics guide for BCIS 4320, and today we're diving deep into Chapter 3, Data Acquisition. This is a core concept in computer forensics. Think of it as securing the digital DNA of a crime scene. If you're serious about digital investigations, hit that like button, subscribe, and ring that bell so you never miss a bite. First up, what exactly is data acquisition? It's the process of capturing a copy of digital evidence without altering the original. Imagine collecting fingerprints. You can't smudge them or add your own. There are two main types of data acquisition. Static acquisition. You power down the device and make a copy. It's safer but risks losing volatile data. Live acquisition. You capture the data while the system is running. It's useful for RAM and active sessions, but tricky since the act of acquisition might alter data. Forensic best practice? Whenever possible, start with a static acquisition. Only go live if you absolutely need data that disappears when the power goes out. Now let's break down the three main digital evidence storage formats you need to know. First, RAW format. This is a bit-by-bit copy of the drive, uncompressed. Advantages to RAW format include that it is fast, universal, and simple. However, it results in huge file sizes and doesn't handle errors well. Another class of formats are what is known as proprietary formats. Think tools like EnCE. They support compression, metadata, and splitting large images into chunks, but not all tools can read them. Still another format is the Advanced Forensics Format AFF, developed by Dr. Simpson Garfinkel. It's open source, flexible, supports metadata, and is platform independent. File extensions include .afd and .afm. Remember, your format choice should depend on tool compatibility, storage availability, and whether you need to include metadata. Now let's talk techniques. There are 4 core acquisition methods. First up, disk-to-image file. This is standard practice and creates an exact clone. Disk-to-disk copy is another method, and while fast for backup, it does not tend to be as secure for evidence. Yet another method is logical acquisition, where you copy only active files or directories, like pulling select emails. Finally, sparse acquisition represents a more advanced method that grabs only allocated files and fragments of unallocated data. Which method should you use? That depends on the size of the source disk, the time you have, and whether the device is encrypted. Pro tip: always document your method. You'll need to defend it in court. Things go wrong, drives fail, power dies, people panic. That's why you need a contingency plan. Duplicate your images using different tools, back up your data, account for encrypted drives. Be aware of host-protected areas, hidden sectors often missed in casual imaging. Remember, if you only have one copy, you have no copies. Now let's talk tools. Some popular acquisition tools include FTK Imager, EnCE Imager, DD, Linux, and Xways Forensics. Windows tools are convenient, but beware, they can't always access host-protected areas. Always use write blockers to protect the original drive. Mini-WinFE is a lightweight Windows boot environment used for safe acquisitions. You boot from it to access a drive without triggering the OS, and thus without altering evidence. Once you have an image, you need to validate it. Validation is how you prove your image is legit. We use hash values like digital fingerprints. Most common, MD5 and SHA1, though SHA256 is gaining ground. You calculate the hash of the original and the image. If they match, you're golden. If not, you've got problems. Never skip hashing. Chain of custody and evidence admissibility depend on it. RAID systems complicate everything. They're built for redundancy, not forensic clarity. You'll need to understand RAID level, RAID 0, 1, 5, etc. Reconstruct the array logically if needed. Use imaging tools that support RAID configurations. For network acquisitions, tools like FTK Imager Lite or live RAM acquisition tools can pull data from live systems, remotely. But beware, remote typically results in more legal oversight. Now let's wrap this up. Data acquisition is the bedrock of digital forensics. It's about capturing the evidence, protecting it, validating it, and doing it all without leaving a trace. Key takeaways. I want you to consider after watching this video, choose the right acquisition method, using the correct format for your needs. Validate everything with hashes. Plan for failure and have backups. If this breakdown helped you, comment your biggest takeaway, and share this with a classmate. Make sure you're subscribed so you don't miss Chapter 4 where we hit the crime scene. Until next time, stay curious and stay forensic.